Hello everyone, I am Arnab. This project is on a very important topic, and that is air pollution. Hope you will like this PPT. We have heard many people talking about air pollution, like doctors, political leaders, news channels. But actually, what does it mean? And some people also say, what can I do to stop air pollution? I am not doing the pollution. It is the work of the big factories which release tons and tons of harmful gases. But is it true? Let's dive into this topic. Before going to the main topic, first let's see what is air pollution. There are many types of pollution: soil pollution, water pollution, air pollution. Now, let's see soil pollution. Soil pollution is defined as presence of toxic chemicals in soil. As you can see in this picture, this is a pic of soil pollution. See how much pollution means plastic bottles, polythene are on the soil. Means, as we know, plastic takes very much time to decompose, so this will harm the soil very much. Now let's see water pollution. Water pollution occurs when harmful substances like chemicals which contaminate a stream, river, lake, ocean, aquifer or other water bodies, degrading water quality and rendering it toxic to human and the environment. As we can see in this picture, there are so much pollutants in water. There are plastic bottles, plastic bags, polythene covers, then shoes, then brush, and oil-like substance or grease. These all are pollutants which pollute water. Now, let's acknowledge about air pollution. Air pollution refers to the release of pollutants into the air that are detrimental to human health and plants as a whole. As we can see in the image here, we can see the factory is emitting very much of smoke which contains air pollutants like carbon dioxide, carbon monoxide and many other harmful gases which can harm our human lungs. Although air pollution is our main topic, not only A sort of factories, if we consider or if we look into the real status, we can not believe that all type of factories make some type of pollution. Now let's see the categorization of air pollutants. Air pollutants are categorized into two phases, aerosol and gas phase pollutants. The term aerosol particulates, which is generally synonymous as liquid and solid phase, but are distinguished from gas and vapors. Besides nitrogen, oxygen, water, argon, and CO2, most other atmospheric constituents exist in trace amount, with the exceptions of molecular hydrogen and nitrous oxide. The remaining predominant gases are relatively non-reactive and stable under atmospheric conditions. From a mass balance perspective, nitrogen and oxygen exist in numerous chemical compounds in the atmosphere. Nitrogenous compounds include a number of air pollutants, especially nitrogen dioxide and many other essential compounds like nitrous, nitrite, and ammonia. Carbon is the distinguishing element for organic compounds like those with CC and HC bonds. But it is also a part of many inorganic compounds, including CO2 and global greenhouse gas GHG and carbon monoxide CO and air pollutants that cause cardiovascular and other health effects. Indeed, carbon is a major constituent of many air pollutants, including PM, which is particle pollution, in various forms, as well as many of the most toxic air pollutants like dioxins, polychlorinated PCBs, and many pesticides and GHGs like chlorofluorocarbons, CFCs, hydrochlorofluorocarbons. The most abundant organic molecule in the atmosphere, its atmospheric concentration increased dramatically after the Industrial Revolution, but is no longer increasing. These include agriculture, as livestock and rice paddies, but also landfills, fossil fuel extraction, and gas distribution, and biomass burning. These anthropogenic sources produce about the same amount of CH4 as natural source, which include reduced exhaust, portions of wetland and portions of ecosystem undergoing organic decomposition. Methane is a more potent GHG than CO2, absorbing 22 times the energy per unit mass. Now, let's see how the pollutants like CH4 and N2O destroyed at the stratosphere. Each gas mixes in the air at different altitude? The mixing ratio is the number density of the gas divided by number density of all gases in dry air. Only N2 and the noble gases have nearly constant mixing ratio below 100 km given their chemical stability. Since most CH4 and N2O are destroyed at the stratosphere, their mixing ratios start decreasing at about 20 km altitude. The mixing ratio of water vapor with a highly temperature dependent concentration decreases sharply with altitude and decreasing temperatures in the troposphere. The stratospheric O3 layer is also apparent at 35 km. As we can see in this picture, atmospheric mixing ratio of ozone and abundant atmospheric gases other than molecular nitrogen and noble gases. It is clear that these are well mixed up to 100 km altitude. Transformation, transport and fate of air pollutants. Air pollutant scales may be categorized from cellular to global, but ambient air pollutants is often subdivided as local, urban, regional, continental and global. The sphere of influence of the air pollutants themselves range from molecular as gases and nanoparticles to planetary as diffusion of greenhouse gas throughout the troposphere. The local scale cover up to about 5 km of the Earth's surface. The urban scale extends to the order of 50 km. The regional scale is from 50 to 500 km. Continental scale are from 500 km to several thousand km. Of course, the global scale extends worldwide. In this picture, it shows the physical movement and accumulation of contaminants after release. Acid rain. Acid rain is specifically the so-called wet deposition of low pH precipitation, but acidified substance also reach the Earth's surface by dry deposition of acid aerosols and by acid fog. As airborne droplets of water that contain sulfuric acid or nitric acid. As we can see in this image, the water of ocean, and there is a land, trees, clouds and a factory. The factory is releasing SO2, sulfur dioxide and NO2, nitrogen dioxide. It is mixing with the cloud, and then when the cloud bursts and rain occurs, then two compounds form, H2SO4 and HNO3, which are very harmful and acidic in nature. It killed trees and then it go into the soil and also decay the soil. And this process takes place As the water from the sea arises, then it mixes with uh, the harmful acidic substance, and then it again fall on trees, which kill them. This is an important example of acidic rain. Here in the picture, there are different images of our earth. This is change in September monthly mean concentration of ozone, means O3, in the stratosphere, indicated by fall color view of total ozone over the Antarctic pole. The purple is and blue color indicate the lowest concentration of ozone, and the yellow and the red shows higher indication. Dobson unit number of O3 molecules of ozone required to create a 0.01 mm layer of pure O3 at a 0 degree Celsius at 1 atm. Here the picture shows the production and destruction of ozone in stratosphere. And if we see closely, at first there is a slow reaction. Oxygen molecule photolyze yielding two oxygen atoms, and in second there is a fast reaction. Ozone and oxygen atom continuously interconverted as 𝑣𝒓𝒏𝒂𝒃. Ozone and oxygen atom reaction with another oxygen molecule, and at third there is slow reaction. Ozone destruction by reaction of oxygen atom or ozone molecule with each other or with other trace gases like chlorine, and this whole process is interconversion process converts UV radiation into thermal energy, heating stratosphere. We have known that air pollution causes many numerous diseases, and respiratory diseases are one of them. Let's see how it works. The primary function of the human respiratory system is to deliver O2 to the bloodstream and to remove CO2 from the body. And these two processes occur concurrently. As the breathing cycle is repeated, air containing O2 flows into the nose and or mouth and down through the upper airway to the alveolar region, where O2 diffuses across the lung wall to the bloodstream. The count flow involves transfer of CO2 from the blood to the alveolar region and then up the airway and out of the nose. Because of the extensive interaction of respiratory disease with the surrounding atmosphere, air pollutants and trees can be delivered to the respiratory system, which consecutively became the region and reason of different dangerous diseases. This image shows the air quality index according to the numerical value, and what happens if it is this or good, moderate or unhealthy for sensitive group, unhealthy, very unhealthy, hazardous. And the ranges is for good 0 to 50, moderate 51 to 100, unhealthy for sensitive group are 101 to 150, unhealthy is 151 to 200, and very unhealthy are 201 to 300, and hazardous are 301 to 500. And they are classified into different categories. Means in good, the air quality is satisfying and there is no risk. And in moderate it is acceptable, but some air pollution gradually become problem. And in third case, the member of sensitive group may experience health effects. General public may not be affected by that. And in unhealthy group, everyone, all the people can experience health effects. And the sensitive group may experience more serious effects, and in unhealthy, very unhealthy, the health warning of emergency condition. Entire population is likely to be affected by this increase of pollution. And in the last and very dangerous, hazardous, there is a health alert. Everyone may experience more serious effects. It can be normal people, healthy people, sensitive group people, and any type of people. They can experience a very dangerous health problem. One of the wonders of seven wonders is the great Taj Mahal. We all once want to go or we have seen Taj Mahal. It is made up of marble, and due to the air pollution, it goes up in the air and then it mixes with the water droplets which are condensing and forming cloud. And when it is precipitating, then it will coming with a very harmful compound and which fall on Taj Mahal and eroding it. There are many such structures which are eroding due to a single reason, that is pollution. So government has taken steps to not to allow vehicles or other factories who pollute the air in a range of Taj Mahal, so that one of our ancient time structure should remain and everyone could see it. Everyone does the pollution, whether it is large factories or a single person. The pollution initially starts from an individual. We have to see this matter in a different manner. See, a business starts from an individual and it grows gradually, and a lot of people come with that business. So pollution is like that. Pollution is first done by individual, then it is correlated with other people and it is increasing. We can see that if we stop pollution, if we stop reducing pollution done by us, then it will gradually, everyone will think that we should stop the pollution. Then gradually everyone will reduce it and the pollution will become very much low. In this way, we have to reduce the pollution. And the conclusion is that the question we have come up with, that is the pollution is done by ourselves or the large factories. The large factories are also owned by individuals, so I think the pollution is mainly done by a single person, and it increases when the more people engage with his or her work.